Saxon Advanced Mathematics, lesson 96, dun, 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 dun. Our last lesson before spring break. It's not something new. It is building on what we already know. So it's a great lesson to end on. And let's just dive in and I'll explain it as we go. What we're going to be doing is that we're going to be using our double angle identities to solve identities. Before we just learned how to derive them, right? We learned how you take the sum identities where we're adding a plus b and you just change it to a plus a. And we learned how to derive them. And then we learned how to derive the half angles too. This time, we're going to be working from those. So get your sheet that looks like this. If you have one, get something like this. Here's where I've got my sum identity for sine, and then I used that to find the double angle. I didn't have to do any work. I could just look at it and get that. I've memorized this one. I don't have to memorize this one. Then I took my cosine sum identity, which I have memorized, and I changed that into the first form. And then using my Pythagorean identity, I substituted in for cosine and then for sine, and I got two more forms for the cosine of 2a. So there's all three of them. These are the ones I would use to find the half angles if I so desired, but I don't right now. And then down here, I worked out the double angle identity for tangent. Again, what I did was I took the double angle for sine and put it over the double angle for cosine. I used the first one, which was here and then here. And then I turned the bottom left into 1 and then had to do the same thing to everybody else and got this as my double angle identity for tangent. So when we use these, what we're doing is we're on the lookout for any time that we have sine of 2a, cosine of 2a, or tangent of 2a. By the way, I put parentheses around this just as a reflex. We don't need to have parentheses around this angle value, but it doesn't hurt if we do. Spoilers, on the test, there will likely be a problem like this one that we're about to do. You will recognize it because it will say lesson 96 in the little code underneath the problem number, right? You know how I do that? So when you see that it's from lesson 96, that will be a heads up that there's likely to be a double angle in it, and you'll be on the lookout for it. All right, let's practice being on the lookout, shall we? Example 96.1. Show okay, we're supposed to show that this quantity squared equals that. Okay, this we know is what's going to stay the same. We're trying to get to that. This is what we've got. Now, we've dealt with this before. We know that when we have essentially like a binomial where we're adding and we're squaring it, we have to do the long multiplication, the dance, right? Just like we do in more basic algebra. So I'm going to write this out so we can do this dreaded multiplication. Sine squared x plus sine x cosine x. I always write them in order, sine, cosine, tangent. Okay, she's done dancing. Sit down. Now this is the same thing. Oh, I just inadvertently turned that into an a. They're all x's. And then this last one plus cosine squared x. Okay, we add it all together and we get sine squared x plus 2 sine x cosine x plus cosine squared x. Okay, that's my whole left side. All right, now I know that sine squared x plus cosine squared x equals 1. Here it is. It's the first of the Pythagorean identities, right? Okay, so I'm going to change this into a 1. 1 plus 2 sine x cosine x. I know that we're trying to get a double angle, and this looks vaguely familiar. So when I go back here, I go, oh, look, this 2 sine A cosine A, it's x in our example, it's A on my page, same difference. That equals the double angle. So I can change this. I can make it 1 plus the sine of 2x, and that's exactly what we're going for. Yay! Not so bad, right? We just have to have these mentally ready. Again, you will be making yourself a formula sheet on the test, an identity data page. So you'll have this information at your fingertips. It helps if they're all written down. All right, and I think we have one more of these. Yes. Example 96.2. This one looks even freakier. All right, well, I like the right-hand side. That looks really cute. I have no idea how we're going to get ourselves there, but that's okay. We will do that. So what I'm hoping to do is to leave the denominator alone, and maybe we can reshape the top. I don't know. Let's see what we can do. This I recognize as a difference of 2 squares pattern, right? That's a perfect square. That's a perfect square. There's a minus sign in between. So if I can find what A is equal to, I can do, and B is equal to, I can do A minus B times A plus B. And the square, that would be cosine squared, cosine squared x, and B would be sine squared x. So I'm going to rewrite this. Cosine squared x minus sine squared x times cosine squared x plus sine squared x, right? I'm just using this basic old school algebra 1 difference of 2 squares theorem to break this down. All right, and I'm going to put this over cosine of 2x. That's just what we had. I didn't do anything new there. This I recognize once again as the first of our Pythagorean identities. We usually write it with sign first, but it doesn't matter. It equals 1. Oh. This then is equal to 1. Beautiful. Now I'm just left with this, and this is looking familiar to me as well. And I recognize it as the first of my cosine double angle expressions, right? Cosine squared A minus sine squared A. That's what we've got. So this is equal to the cosine of 2A over the cosine of 2A. What? That cancels. It equals 1. And there we have it. Oh, that's not so bad, right? We just had to, here we had to do this ugly squaring of the binomial. Here we had to use the difference of two squares theorem. That is the most important part to both of these, okay? Will a problem like this be on the test? Yes. Ask me if you have any questions. Now, the rest of this lesson, as you can see, there are quite a few. We've done this much, right? More double angle identities. Here is the good news. These 3 additional sections are proofs, more or less. Here, John proves to us the triangle area formula. Well, we know that to find the area of a triangle, you need the base times the height divided by 2. John just proves it. He feels strongly about it and he proves it. Okay, great. No examples. He just wants us to understand that that formula can be proven given the level of understanding that you now have. That's kind of cool. You learned this formula years ago, probably back in middle school, right? Area of a triangle equals base times height divided by 2. Now he's showing you how it's derived. Cool. Down here, he's showing you how to prove that the law of sines will always work. Again, and there's more up here. I mean, cool. I consider this more appropriate for college level mathematics than it is for high school. I don't want you to clutter up your brain with theory. I want you to be very focused on execution. And then here's the third part. Equal angles imply proportional sides. We've known that forever, right? That if your angles are the same, then you can make proportions out of the sides. He uses the law of sines to prove why that is true. And it goes over onto the last page. So these 3 additional topics, the triangle area formula, proof of the law of sines, and why equal angles imply proportional sides, here are the theoretical explanations as to why all of those things are the way that they are. And if you decide to pursue mathematics in the long term, I hope that you will drink that up. It's cool, it's fascinating, but I would much rather that, again, you focus on execution of problems rather than the theoretical basis. So I'm not going to clutter your mind with that. I am instead going to say, memorize this. Hard, cold. Memorize this. Hard and cold. Learning to execute comes before understanding philosophy, and that's what I'm focused on. I want you to learn how to execute this information. All right, so that is all we're going to cover for lesson 96. I don't think that there are any homework problems that cover those 3 different proof areas that I showed you. I believe not. If you find one, skip it, and please let me know that it exists. This type of problem, yes, definitely on the test, these double angle identities. Please make sure you understand and can execute that kind of a problem. Yay! Ready? Here comes the ceremonial crossing off. I will see you this weekend for review problem number 12. Remember, we're going to drop one because we did 2 that week. Yay! I look forward to talking to you soon. Goodbye.